Hi everyone, my name is Radis, and this is my causal network Teach One assignment for Half 823. So what is a causal network? A causal network is a collection of interrelated causes and their effects. By interrelated, we mean that one cause can have an effect that can cause another effect. No variable is unrelated to anything else. Variables that are not related to the network are simply ignored as they are not relevant. A causal network is a collection of nodes and directed links among pairs of nodes. Each node represents one variable and each link a relationship among a pair of variables. Causal graphs can be drawn from independence assumptions. If two variables are directly related to each other, they are shown by a directed link, which can be seen in question 7's network model. The network model is used to simulate data on bundling payment for total hip fracture treatment. Does the variable h have an impact on BP? If they are indirectly related to each other, you can start from one variable and follow the links and reach the other. If two variables are unrelated, then there should be no link between them, and one cannot follow the links shown in the graph to reach from one to the other. For instance, LTH is regress in all variables that precede it, which are DME, CL, P, and H. But only P and H have a statistically significant relationship with LTH. In the equation, the statistically significant relationships are shown with a star. A missing star in this case indicates an insignificant relation. Other equations were created in representation to the above network. For BP, the preceding variables are represented by a direct arrow when they have a statistically significance to the outcome variable. For instance, the stars, when they have a star right next to them, that means ideally that they have a direct correlation to the outcome variable, which in this case HOS, HL, OT, PBD, RF, not SNF, sorry, SNF, HHA, H, and that should be it for the outcome variable BP. These are the rest of the set equations represented in this graph. And like I said earlier, the stars mean that they are statistically significant, or there's an arrow directly if the preceding variable is directly correlated to the outcome variable. Therefore, can these set of equations be used to create the network? In how many ways does the regression equations differ from the network model in the graph? The set of equations above can be used to create another network by including only the nodes that are statistically significant in each regression equation. Every equation made will make the network different from the original one, if only the statistically significant parameters will be included in the revised network. So once we download the data from our online source, make sure to delete column A, as this does not have any value to our data. But if you don't, just make sure to change your numbers throughout the R. But it will make everything so much easier if you just delete the first column. And then we start using R. In this case, the PLYR package in R is will be installed along with catnit and bnlearn. The PLYR package in R is a set of tools for a common set of problems such as splitting, applying, and combining data. In many cases, PLYR is as fast as or faster than the built-in equivalents. The R package CatNet provides an inference framework for categorical Bayesian networks. BNLearn is an R package which includes several algorithms for learning the structure of Bayesian networks with either discrete or continuous variables. Once we have those installed, we can go ahead and read the simulated data. And first, we can prepare our counts of the various combinations of variables by using the equation listed. Data counts equals dd ply data 1 to 13 and row. And the counts will be seen as V1 later on as we look through the results of the equation. Finally, a log linear regression using the counts, which said earlier is the V1 column as an output. And we can include all pairwise interactions between them. And the result is shown here. We can use this finding and we can compare our network model from the previous slides. So the ones that are statistically significant in this case, do they match our network model? Next, we can organize our variables or our network model and separate them by times. The main goal is to find the cause and effect for each variable and to determine the causal impact of the preceding variables to the outcome variable, which in this case is BP. The data name is changed to D in order to have a consistent data table name throughout the process. A log linear model, as mentioned earlier, is used since our explanatory variables are all discrete. This model is equivalent to Poisson regression model, which is shown in the R code above. Since we are getting to time 3 when there are outcome variables and their preceding variables may or may not have a direct relationship, from this equation we are finding the Markov blanket of each variable and placing them into a vector called C. And this is shown on this slide. Now do the same for all the other variables. Compare results from R to the network model. Does the outcome variable match with the preceding variables? Thank you for watching.